So in this video we're going to look at the situation where we have a triangle where we know two angles and a side, and we're going to use the law of sines to solve that triangle. So here we have a triangle. We know two angles, 29 degrees, 121 degrees, and we know one side, 89 yards. So this is an angle, I know angle, side situation, but what we indicated in the previous video was that if I know two angles, I can easily get the measure of the third angle by going 180 degrees minus the sum of these two angles. So I really do have, if I have an angle side situation, I really do have an angle side angle situation as well. They're equivalent cases. They both can be solved with the law of sines. So the first step in doing this is to give everything names. So I'm going to call this angle A, this angle B, and this angle C. And then our side lengths are going to be little b opposite angle B, little c opposite angle C, and this will be side length little a. So then you just catalog what you know. What do I know? And what do I not know? And if we're solving a triangle, what we're doing is trying to figure out the pieces that we don't know. So in this case, because of my labeling convention, I know A. A is 29 degrees. I know B. B is 121 degrees. And I know little a, which is 89 yards. And probably the first step here is to get the third angle, because that's going to be the easiest thing to do. So I'm going to get angle C. We know that C is going to equal the 180 degrees that a triangle sums up to. The angles of a triangle sum to 180 minus the sum of the two angles that we already have. So this is going to be 180 degrees minus these add up to 150 degrees. And so when we take this difference, we get a 30-degree angle. So first, the next step, I'm going to go ahead and get side length C. And we need three pieces of information. So I'm going to use angle A and side length A, angle C and side length C. And before I do this, what we want to recognize is that if we are solving from the law of sines, the ratio sine A over side length A equals sine C over side length C. If we have a relationship like this, it's just as legitimate an equality to reciprocate that relationship. So if this is true, then this is true. If a half equals 4 over 2, then it will also be the case that 2 over 1 equals 4 over 2. And the reason I bring this up is my suggestion is typically to take the unknown that you're trying to solve and just start with that unknown in the numerator position. So if I want to find side length C right here, I'm going to start by putting C in the numerator position, and then I'm going to put it over the sine of the angle, which is 30 degrees. Equals, and now we grab the angle for which we know the opposite side length already, so it's going to equal, and then I'm going to put the yards in the numerator and the sine of the angle in the denominator. So reciprocated from how it's usually written in a textbook, for example. And the reason for doing this is it's easy to just multiply both sides now by the sine of 30 degrees, which will isolate side length C. So we get 89 sine 30 degrees over sine 29 degrees. And before we move forward, there's some things that we should notice here. Sine 30 over sine 29 should be about 1 because these two angles are almost the same. So we should get a side that has length close to 89. So that makes sense, because if this angle and this angle are almost the same, we would expect the measure of the opposite sides to be close to the same as well. The other thing to notice is that this is a special angle, so we could replace the sine of 30 degrees with a 1/2 if we wanted to, and we could write 89 over 2 times the sine of 29 degrees, because multiplying by a half is going to put the 2 down in the denominator, and this would be in yards. And if we were being asked to find the exact answer, this would be the exact answer simplified as much as we could. Probably in this case, a typical homework assignment would probably ask us to approximate the answer, for example, to the nearest tenth. So we'll go ahead and approximate it. So I'm not going to do this step here. This can just chunk straight into the calculator, 89 times the sine of 30 divided by the sine of 29. And the only thing you need to be careful to do when you chunk it into the calculator is to make sure that you are in degree, not radian mode, because our angles have been given to us in degrees. So if we put this into the calculator, we're going to get 91.8 yards. That's rounded to the nearest tenth. It was 91.7886 blah blah. And so I can't use the equality sign here. I just rounded, so I'm going to put the approximation symbol in here. And now I can step up here and say, now I know what side length C is, 91.8 yards. And this is an approximation, not exact, so I'm going to change this to approximately. And I'm not going to use this number in any further calculations because I have approximated it. So to get side length B, I'm going to use this angle and this measurement, which I have in an exact form, and I'm going to use these pieces of information here to solve for B. I'm not going to use angle C and side length C because I've approximated this number. So I'm going to step over here and I'm going to say, now I want to know B. So it's going to be side length B over the sine of angle B, which is 121 degrees. It's going to equal side length of A divided by the sine of A, which is 29 degrees. And then I multiply both sides by the sine of 121 to get the B by itself. So we get B equals 89 sine 121 degrees divided by the sine of the 29 degrees. This would be yards, and this answer right here would be exact. And if I were asked for the exact answer, I would stop right here. More common, it will be to be asked for a rounded answer. So in this case, it rounds in the calculator to 157.4 yards. So the B, little b, is 157.4 yards. And you have solved the triangle once you have all the unknown measurements.